Okay, pre-calculus students, last unit we'll be diving into for the rest of the school year. Unit 6, and it's about identities and equations. Identities are an expression that is the same as another expression. Or you could make it the same as an equation is an identity. If you say x equals to 2, that's an identity for that particular problem. If you say x plus 2 equals to x plus 4 minus 2, that's an identity. It's the same thing on the left and the right. So today, day 1, we're going to do some basic, very basic, that you can't leave pre-cal without having an understanding of some basic identities. We've already looked at some that are reciprocal. We've already looked at quotient. You just don't know it. But new ones would be Pythagorean, cofunction, even and odd. I can give you I did give you a copy of this trig identity chart. Again, this can be added to your cheat sheet. You can use this whenever you need to, especially until you get really good at these identities. Proving is the same thing as verifying, because what they've done here, they now gave you an equation with an expression on the left and an expression on the right. We want to prove that this is a true statement. What we want to do is pick a side that's the most ugliest and try to simplify it and see if we ever get the cosecant. So you pick one side. Now, obviously, the left is the ugliest.
Wait, wouldn't that just be 1? There 1? Because there's cosine squared theta plus.
No, because there's a multiplication in front of that. This is this times this and then adding. So I know it almost looked, if they'd have put a parenthesis here, you would have been correct. But I don't see a parenthesis there. And it seems like it already worked out. Cosecant times 1 would be cosecant. But I don't think that would have been a legal move, because I don't believe they intend that to happen. So I clearly see a dot on their write-up. So what I might do is, well, a cosecant times a cosine. Let me turn all the sines and cosines. 1 over sine of theta times cosine squared theta. And then when I get done with that, I got to add a sine of theta. Now, that doesn't mean much to you, but I think we have an identity for cosine squared, if I'm not mistaken. I think we figured out that 1 minus sine squared theta is cosine squared theta. I think we talked about that before, using the sine squared theta plus cosine squared theta is a 1. I can move the sine squared to the right, leaving cosine squared. So let me substitute in for that then. And again, I'm winging it. I don't have a secret. I wish I did have a secret, but I don't. 1 over sine of theta, all times 1 minus sine squared. Then I'm going to have to add a sine of theta to it, see what happens. So the time is 10:31. Did you put the time? So if I distribute this fraction, I'm looking at 1 minus sine of theta minus sine squared theta over the sine of theta. Does anything happen here? What's sine squared theta divided by a sine?
Just be sine.
Yeah, 1 over sine of theta minus sine of theta over 1. I don't even know what's going to work. Oh, I keep forgetting to write down this plus sine of theta. Plus sine of theta. So what I'm going to do, oh, wait a minute. Thank God I saw this. 1 over sine of theta minus sine of theta plus sine of theta. Tell me what this is. Minus sine of theta plus sine of theta. What is that?
0.
It's a 0. Those two things canceled out. And had I not brought down that sine of theta right here, I wouldn't have seen it. These two cancel out. I'm left with sine of theta, 1 over sine of theta, which is what?
Is it cosecant?
A cosecant of theta. Isn't that what I was trying to prove? So I say cosecant of theta does equal cosecant of theta. And here's what mathematicians do when they say, they do this. Dot, 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 QED. It means, in Latin, I proved it. I just proved it by doing all this algebra. So all I really did was the same lesson as lesson 2, is I simplified the left-hand side. I crossed my fingers, I said a couple prayers, hoping that it would simplify to the cosecant. There was at least 3 points in this problem where I wasn't sure it was going to work. Sometimes it doesn't work. And you got to start all over.
It says cosecant equals to what? What is that?
1 over sine of theta is a cosecant of theta. These two things are equal. So I wrote cosecant of theta equals cosecant of theta, which was this thing here. And I put 3 dots just to be sarcastic. And I wrote QED, which you don't have to do that. I'm just showing off.
Wait, so what's the answer?
Now, the answer was proving that the left side is the right side. That is the answer. When they match, then you know you got it right. Yeah, this is not like there's a final answer. Matter of fact, if I look at number 2, and assuming that it is true, why would they give it to us if it's not true? They want us to prove it, verify it. Then the final answer, you decide which side is the ugliest, then the final answer would be, okay, that would be the final answer. Or what if Gabriel thought to himself, no, I think the right side is uglier, so when I get this side, that's the final answer. So there really is no final answer. It's pick a side, and in my opinion, Jasmine, are you paying attention?
Yes, sir.
Because you didn't ask any problems for the other lesson, so we just moved on to verify, because this gives us more practice at simplifying. Which side you think would be more complicated to you? Maybe sometimes it's a tie, and just go with your gut and pick one. Somebody pick a side. Okay, we're going to go the right side. So that means I'm going to stick with the right side and try to simplify the right side. You didn't give me much help because secant and cosine being subtracted is not an identity. So let me write secant as 1 over cosine of y. Let me keep cosine of y as cosine of y over 1. Well, there's not a whole lot that I can do with this step. The only thing I can do is combine them into one fraction. Da-da-da! Time for the magic fractions. Start from the right, multiply straight up. 1 times 1 is 1. Put a minus sign, because that's what's here right here. Go to the left, multiply straight up. Cosine times cosine is cosine squared y all over the two denominators multiplied together. Cosine of y times 1 is a cosine of y. Ooh, I see something beautiful. Yen, look at this. The denominator is cosine of y. The denominator is cosine of y. Maybe it's working. So if somebody could tell me what 1 minus cosine squared y is.
Sine squared.
It is sine squared. Remember this thing I wrote over here? Sine squared plus cosine squared is 1. And if I move the cosine squared to the other side, I get sine squared theta equals 1 minus cosine squared theta, which is exactly what I have. So I have sine squared y over cosine of y, which is exactly what I have on the left-hand side. So what do I say? Dot, 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 QED. I just proved it.
Wait, what is QED?
I don't remember what the words are, but it's in Latin. You could Google it if you want for me.
Wait, so do we have to put QE?
No,
Okay.
So do I just put a check?
I just like to do it because it makes me look smart. That I proved it. It's some Latin term that in high sophisticated. Oh, I have demonstrated. Yeah,
Look at you.
as demonstrated.
Look at you knowing Latin, sir. Look at you.
Yeah. Well, I couldn't remember it though. It's one of those things that if you don't use it, you lose it. All right. Okay, your turn, Jasmine. Which side? Oh, yeah. Which side? Number 3. The left or the right is the most complicated side?
Let me look at it. I'm gonna be honest with you, sir. I think it's the right side.
You would be nuts if you said the left. What the heck am I going to do with that left to try to make it look like the right? There's nothing to do over there on the left. So I'm going to start with the right side. You only play with one side. You don't play with both sides. So I'm going to turn everything into sines and cosines. Well, the sine squared is already in a sine. And the times cosecant would be times 1 over sine of A. Outside of that, I still have minus a sine of A, and that's being squared, I think.
Wait, so we'll go 1 over sine of B squared too.
Oh, yeah, I didn't see that because I didn't see the exponent. Thank you. Wait, no, there's no parenthesis there. There's a parenthesis here. All right. So do you see anything that jumps out at you that's gone? Because there's really a sine squared over 1 times 1 over sine squared. What cancels?
It will just become 1.
It all becomes a 1 because the sine squared cancels out the sine squared. So now I'm left with a 1 times 1, 1 times 1, 1 minus sine squared A. Oh, we already had this a minute ago. What's another name for 1 minus sine squared A? Cosine squared A, dot, dot, dot. There it is. Dot, dot, dot. Q, E, D. I proved it. I demonstrated it. I'm the king, or the queen, or the prince, if you want to be a prince, or a princess. Number 4. How many are left on this page? Oh my God, they're getting uglier. Let me be honest on the homework. Let me go look at the homework. Number 4. Yeah, and would you agree with me that the left side's more complicated? You definitely can't manipulate cosine. What are you going to do with cosine? There's nothing to do. This is probably one we've already done. We probably already did this problem in one of the other last 2 lessons where we simplified or something, and it came out to cosine by accident. Well, now I hope it comes out to cosine. Do I want to turn to sines or cosines or leave it in secants and tangents? I think this time, since we've done this already with sines and cosines, one like this, I think I'm going to keep the tangent this time. You don't have to. You can do it your way. And I'm going to do my magic fractions with this secant times a secant. That gives me a secant squared x minus. Now I have a tangent times a tangent, which is a tangent squared x. And my denominator is a tangent of x times a secant of x. Which, by the way, there is a tangent on the outside being multiplied. And instead of multiplying this to both of these, I'm not going to do that. I'm not going to do that. I'm going to cancel the tangent right now. It cancels with that tangent. So I'm left with secant squared x minus tangent squared x all over a secant of x. Now, if you wanted to, you could probably go to sines and cosines right now since it's simplified. But is there an identity that uses secant squares and tangent squares? I think there was. I think it was tangent squared x. Is it a plus 1?
Yeah.
Equals to secant squared? I guess I lied to you guys. I told you that I don't have those memorized, but look at that. I just did it. Why? Because I've been doing it for the last 3 or 4 days, right? So it's kind of like, okay, once you use them a lot, it stays with your brain. Once you quit using it, they're gone. So in a year from now, I'd have to look at the cheat sheets or derive it myself again. So let's see, tangent squared plus 1 is secant squared. Why don't I take this secant squared and substitute it for this tangent squared plus 1? I see magic happening. Tangent squared x plus 1 minus tangent squared x over a secant of x. Do you see anything that cancels out there in the top? It's like saying x plus 1 minus x, or x squared plus 1 minus x squared. Do you see what goes away?
The tangent.
The tangent squares cancel out. One's positive, one's negative. I'm left with 1 over secant squared x. What's another name for 1 over secant?
Cosine.
Cosine squared x. I forgot what I'm trying to prove. Uh-oh. That's not what they have here. Oh, wait a minute. Oh, it's because it's not secant squared. It was just a secant x. I got scared for a minute. It's not a secant squared at the bottom. Take a look at it and you verify it with me. Why is it not erasing? The whole thing. Here it goes. Let me rewrite that better for you. It was, the bottom was a secant of x. So that should have been a 1 over a secant of x, which is just a cosine. Da, da, da. So we had it right. Gabriel, number 5. What side looks like the ugliest side?
Right.
No, there's no question about it, right? Now, you're an algebraic kind of guy. Can you see something I can do on the right-hand side that is a legal math operation when we're trying to pull things out of a set of things with the F word?
Factor.
You could factor out a what? If I wrote it like this, 5 minus 5x.
5.
Yeah, you'd pull out the 5, right? 5, 1 minus x, right? So what am I really pulling out?
You pull a square.
A cosecant squared, yes. So if I factor out a cosecant squared theta, that would give me a 1 minus a sine squared theta. What is another name for 1 minus sine squared?
Cosine.
That gives me cosecant squared theta times a cosine squared theta. I don't see a whole lot to do, so maybe I'll just use that identity for cosecant and call it 1 over sine squared theta times cosine squared theta over 1. Top times top. 1 times cosine squared theta is cosine squared theta.
Like cotangent.
Over sine squared theta is cotangent squared theta, which is what I was trying to prove. Da, da, da. QED. And I'll do one more and let you loose on your whatever you want to work on, because you've been a good audience. Of course, Jasmine keeps hiding over there, and I think I do got to move Jasmine, though. I'm worried about you, Jasmine. You need this class. You're graduating this year. You don't get the benefit of taking this next year. Ah, finally. Number 6 has all kinds of negative angles. Obviously, the left side is uglier than the right side. What's another name for tangent of a negative angle?
Negative tangent?
A negative tangent, that's right. What's another name for sine of a negative angle?
Negative sine.
Negative sine of the angle. What's another name for cosine of a negative angle?
Negative cosine.
Nope.
Oh,
It was 2 out of 3 is not bad. It just becomes positive cosine of u. Now,
Wait, is that a 1?
no, it was my u. Let me back up. At the end there, I made a u, an ugly u. So I have a negative times a negative. That's going to go away. And so that really becomes, I think I'm going to go and turn it into sines and cosines for a minute. A positive sine of u over a cosine of u times a sine of u over 1 plus a cosine of u. I'll just leave that alone. Sine times sine is sine squared of u over a cosine of u. Oh, now I'm going to put a cosine of u over a 1. Oh, I'm going to leave it like that. I'm going to do my magic fractions. See what happens. 1 times sine squared is sine squared u plus cosine times cosine is cosine squared u, all divided by the denominators. Cosine times 1 is cosine of u. What's another name for sine squared u plus cosine squared u?
1.
1 over cosine of u. What's another name for 1 over cosine of u?
Secant.
Secant of u. Is that what I was looking for?
Yes.
Do you hear the angels singing? Hallelujah. No. Yeah, hallelujah. Hallelujah. Yeah, to me, it's every time this happens, I am like astounded that it worked. Because you know in life, there's no guarantees. All right, I will, you know what I might do? I might post this for the rest of the classes to watch before they come to my class. And then I'll move on to the second page. That way I can give more class time to work. As I said, the homework is going to only be, I'm going to call it quits for right now. Where I was? To be these 6. Only 1 through 6. That's enough torture, okay? And you have an extension because I'm going to have to go over this when the whole class is here on Thursday. So you guys can get a head start, if you want to. Or make sure your 1 and 2 is perfect, because I'll be picking all these up at one time, 1, 2, and 3. We go back to 1 through 6. So it's too many of them. I would only assign homework